Hi everyone! In this video, I will demonstrate how to program the PLC to synchronize the drives using a CAM profile. Here is the software that I will use, and the hardware will be the same as in the previous video, but I will also include a Festo PLC. I'm going to start by opening CODESYS and creating a new project based on my PLC of the type CPXE. Here I'm selecting the device type and I add the EtherCAT master. Now, I need to add the two drives to the EtherCAT master, which are the EtherCAT slaves. Here I need the soft motion devices. I'm going to call the drive of the conveyor master, in order to show that this is the master axis. And I will rename the other drive as slave, since this will be the slave axis. In the master axis, I'm going to use a modulo of 140 millimeters, and for scaling, I will set the increments to 1000. I select modulo and 360 degrees on the slave axis and increments are 1000. I will show you now a library that we need to install to easily synchronize the master and slave axis. It is called Synchronized Drive Control and can be found on the Festo website by writing on the search field Synchronized. After downloading it, you just need to decompress it and install it in CODESYS. Once installed, the library needs to be added to the project. Now I'm going to insert the function blocks of the library in the main program. I need the function block called FB-axis control to manipulate the conveyor master axis. The first input will be the master axis. The second input is the ID of the axis, used to identify the axis in case of an error. I just created a variable for the third input to set the dynamic values used for the manual movements. The next function block I need is called FB camming and it couples or decouples the slave drive to a master drive running a camming table. Here I specify the name of the slave axis, the ID of the axis, to identify the axis in case of an error, the input variable like in the previous function block, and finally the master axis. I'm going to create an action with a small function that I need for the visualization, which is very useful if you need to select between several CAM tables. I will create this block to call the action. I now add the last input, which is a pointer to CAM reference. I copy and paste these variables and write on the inputs fcamlist.pactcam. I'm done with the code and will proceed to do the visualization. I look in the visualization toolbox for the Bezier axis SM control, assign it to the function block and add it to my visualization. Similarly, I look for the Bezier axis scamming, assign it to the function block and add it to my visualization. Finally, I add this element to select the list of CAM tables and assign it to its function block. I will now proceed to create and design the CAM table. This is the information needed to create a CAM table for my Rotary knife application. The initial position of each drive should be 0 and both axes are synchronized. The position number 1 is when the synchronization of the axes is finished. The position number 2 is when the synchronization of the axes should start. And the position number 3 is the same as the initial position where both axes are synchronized. I will use these values to create my CAM table in the PLC. By right-clicking on the application, I can create a CAM table. And by clicking on Cam Table I can modify the values according to my table. Finally, I just add my program to the EtherCAT task. Let's test it with the hardware. I just have to search the PLC and download the program. Now I go to the visualization. I click on this button to take control, enable the conveyor and jog it in the positive direction. Now in the negative direction. Here I can home the conveyor. Here I can take control of the rotary knife. I enable it and jog it. Here I can home it. With this button I load the cam table and with cam in I activate it. Now the drives are in synchronization. This means that whenever I move the master, the slave will follow according to the cam table. Now I'm going to set the conveyor to a speed of 10 millimeters per second. And as you can see on the right, the rotary knife is following it. I'm going to increase the speed. And finally, I click on Cam Out to turn off the synchronization. Thanks for watching. Have a great day.